Welcome to TechNova Podcast. All right, so listen to this. There's a new asteroid out there. They've discovered 2024 YR4, and it's got everybody in the astronomy world talking. I know what you're thinking, like, oh, no, here we go again. Is this another, like, doomsday asteroid situation?
Right.
But hold on, it's not quite like that.
Yeah,
What's got everybody kind of on edge is that this one's got a ranking of 3 on the Torino scale.
that's right. 3 out of 10. Now, that may not sound too alarming at first, but you got to think back to Apophis back in 2004. That got a 3 as well, and that really shook things up in the planetary defense community.
Yeah, that was a big deal. And so for people who aren't familiar, what does a 3 on the Torino scale actually mean for us here on Earth?
Okay, so the Torino scale, it's basically just a way for scientists to communicate the hazard potential of an asteroid impact.
Yeah.
It takes into account a bunch of things like the size of the asteroid, its speed,
Yep.
and most importantly, the probability of it actually hitting Earth. So 0 in the scale means there's basically no chance of impact, and then a 10 on the other end of the scale, that means we're talking like a global catastrophe.
Gotcha.
So a 3, while it's still a low probability, it's something that we need to be watching and analyzing carefully.
Okay. And to be clear, with 2024 YR4, we're looking at a 2.1% chance of impact. Is that right?
Yeah, that's the latest estimate, yes. And it's important to stress that that is a very small chance.
Right.
But even a small chance of something, pretty significant happening, it grabs your attention.
It definitely does. And speaking of grabbing attention, we've got the James Webb Space Telescope getting involved in this.
That's right.
They're going to be observing 2024 YR4 for about 4 hours next month using its mid-infrared instrument, or MIRI.
Yeah.
I mean, that's got to be exciting for you guys.
Oh, absolutely.
Yeah.
James Webb is like a total game changer. It's going to be studying the thermal energy coming from the asteroid, and that'll help us figure out how big it really is.
Okay, so we're like taking its temperature from millions of miles away.
Yeah, basically.
But why is knowing the temperature so important?
So the thing about thermal imaging is it can actually tell us a lot about what the asteroid's made of.
Okay.
Different materials, they give off heat differently. And that information that helps us figure out its density and its structure.
Interesting.
And that's really important when you're trying to predict how it might behave if it actually did enter the Earth's atmosphere.
So it's not just about the size, it's also about what it's made of.
Exactly.
Okay, so to really get into all of this, I'd love to introduce our expert on asteroids and planetary defense. Welcome to the deep dive.
Hey, thanks for having me.
All right, so let's get down to the basics here. What are we dealing with when it comes to the size of 2024 YR4?
So right now, the best guess we have is somewhere between 150 and 300 feet in diameter.
Okay.
So, just try to imagine something maybe the size of a football field or, even getting close to the height of the Statue of Liberty.
Wow, that's not exactly tiny, but you mentioned those are just estimates. Why the uncertainty?
So the way we figure out its size right now is by how much sunlight it reflects.
Okay.
But you can think of it kind of like trying to guess the size of a car just by looking at its headlights from really far away.
Yeah.
You can get a rough idea, but you're missing a lot of details.
Yeah.
We need more information, and that's where James Webb comes in. By studying the thermal energy, we'll get a much clearer picture of its true size and what it's made of.
So let's just say, hypothetically, this asteroid with its, football field size stature did hit Earth. What kind of scenario would we be looking at?
Okay, so first off, it's important to remember that objects this size, they have hit Earth before.
Okay.
This isn't a planet-killing extinction level event. We're not talking about that.
Okay.
The impact would be big, yes, but it would be localized. It wouldn't wipe out humanity or anything like that.
Okay, well, that's a bit of a relief, but still. I mean, what would it look like? Are we talking like a Hollywood fiery explosion?
Well, it would be a pretty impressive sight, but the scale of the impact would really depend on where it hit.
Yeah.
If it landed in a populated area, the damage would be significant. Buildings would be destroyed. There would be casualties.
Mm-hmm.
But statistically speaking, there's a high probability that it would actually land in the ocean.
Which I'm guessing would have a whole different set of consequences.
Exactly. And ocean impact would still be dramatic, creating, massive waves and tsunamis. But the risk to human life would be a lot lower compared to a direct hit on land.
So like a giant splash and some really, really big waves, I mean, that's definitely something we can visualize.
Yeah.
But it seems like we're talking about probabilities here. How good are we really at predicting the paths of these things?
So our ability to track asteroids and predict their paths has gotten a lot better in recent years. We've got a global network of telescopes constantly scanning the skies.
Yeah.
And we're getting better at identifying and categorizing these objects all the time.
That's reassuring. You mentioned a global network of telescopes. Can you tell us a bit more about how those actually work? How
Yeah.
do you find a small rock hurtling through the vastness of space?
It's pretty remarkable.
Yeah.
We use telescopes both on the ground and in space. So ground-based telescopes, the ones you might imagine on like a mountaintop, they scan sections of the sky, taking multiple images.
Okay.
And by comparing these images, we can see anything that's moved against the background of stars. It's like finding a moving needle in a cosmic haystack.
That's some serious detective work. And what about the space-based telescopes? What advantages do they offer?
So space-based observatories like the NEOWISE mission, they have the advantage of being above Earth's atmosphere.
Mm-hmm.
So that gives them a much clearer view of space. They can detect objects that are fainter, and they can cover much larger areas of the sky, and they're constantly watching, providing us with data about potential threats.
So we've got a whole army of telescopes looking out for us. That's comforting. But what happens if one of these, needles turns out to be on a collision course with Earth? I mean, what steps would be taken to, save the day?
Well, the good news is that if 2024 YR4 or any other asteroid for that matter was confirmed to be on a collision course, we'd have years of advance notice.
Yeah.
It wouldn't be like a surprise out of nowhere event.
Right.
We'd have time.
Yeah.
We'd be talking about a time scale that allows us to develop a plan and put it into
You
action.
plan to save the world, no less.
Yep.
All right, well, we're going to have to leave it there for now, but when we come back, we'll dive into what that plan might actually look like, what options we have, and how prepared we really are for this kind of cosmic challenge. So stay with us. Welcome back to the deep dive. Before the break, we were talking about that possibility of an asteroid hitting Earth specifically. 2024 YR4.
Yeah.
Thankfully, we have some really bright people working on, how to protect our planet if something like that were to happen. So let's get into that. I mean, what are our options? Are we talking like Bruce Willis and a team of roughnecks drilling into an asteroid?
That's a classic. But luckily, our real-life strategies are a little more advanced than that.
Okay, so no nukes in space. What are some of the more realistic options?
Well, there are a number of things that scientists are looking at. And the best way to go about it would depend on a few factors. The size of the asteroid, what it's made of, how much time we have, and the path it's predicted. To take one method that looks promising is the kinetic impactor.
I've heard of that. So you basically just slam a spacecraft into the asteroid to knock it off course.
Exactly. You want to transfer enough momentum to slightly change its trajectory over time so that it misses Earth completely.
Fair.
It's kind of like playing a game of cosmic billiards, where the cue ball is the spacecraft and the target is that dangerous asteroid.
And we've actually tried this out, haven't we?
Yeah, in 2022, NASA's DART mission successfully hit the small asteroid Dimorphos.
Right.
They crashed the spacecraft into it on purpose, and they were able to change its orbit. The results were really promising and proved that the idea works.
Wow, that's incredible. It's amazing to think that we're actually at a point where we can nudge these objects around in space, but what if we're dealing with a much larger asteroid or one that we don't spot until later? Would a kinetic impactor still be the best option?
For bigger asteroids, or ones where we have less time to prepare, we might need to try something different. One idea that's getting a lot of attention is the gravity tractor.
The gravity tractor? What is that, like a cosmic tow truck or something?
It's a good way to think about it. Basically, a gravity tractor would be a spacecraft that we position near the asteroid, and we use its own gravitational pull to very gently tug the asteroid and change its path over time.
So you're not hitting it, you're just kind of gently nudging it away from Earth?
Yeah, it's a much slower process, but it could be very effective for moving larger asteroids, especially if we have enough warning time.
It's really amazing the tools we're developing to protect ourselves from these threats from space. It seems like we're stepping up our game when it comes to planetary defense.
Definitely. But we have to remember that we're still in the early stages of developing and testing these technologies. There's still a lot more research and testing to do.
Right, and I imagine there are challenges too. What are some of the biggest hurdles we face when it comes to planetary defense?
I think one of the biggest challenges is being able to detect these asteroids early. The sooner we spot a potentially dangerous asteroid, the more options we have for dealing with a risk. And that means we need to keep investing in telescopes, both on the ground and in space. The more eyes we have on the sky, the better our chances of finding these objects before they find us.
It's almost like a race against time. We have to see them before they get too close for comfort.
That's right. And even after we find an asteroid, there's still a lot to do. We need to figure out how big it is, what it's made of its trajectory, and whether it really poses a danger to Earth.
It sounds like a very complex process with a lot of things we still don't know, but it also sounds like an amazing field to be working in. What made you interested in this area of research?
I've always been fascinated by space, by how big it is and all the mysteries it holds, and the idea that we're actually coming up with ways to protect our planet from these threats from space, well, that's incredibly exciting to me.
Yeah, I can see why it would be. It's a field that brings together science, technology, and even a little bit of adventure, all for the purpose of protecting our future.
That's a great way to put it. It's a reminder that we're all part of something much bigger than ourselves.
Yeah.
And it shows how important it is for different countries and scientists to work together.
Speaking of working together, what's the role of international partnerships in all of this?
They're absolutely essential. An asteroid impact doesn't care about borders or politics.
Mhm.
It's a threat to everyone on Earth, and it requires a global response.
Right.
We have to share data resources and expertise if we want to protect our planet effectively.
Yeah.
Luckily, we have organizations like the International Asteroid Warning Network and Space Mission Planning Advisory Group, which helps scientists and space agencies around the world communicate and work together.
That's really good to hear. It sounds like there's a genuine sense of global unity when it comes to this issue.
I think so. We're all in this together. And I believe that if we work together, we can overcome these challenges and make sure that humanity has a safe future.
Well said. It's inspiring to hear your passion and dedication to this field, and it's comforting to know that we have people like you working so hard to protect us from these threats from space. Now, before we wrap things up, let's take a moment to look at what the future might hold for this incredibly important area of research. We're back and ready to wrap up our deep dive into planetary defense. Before the break, we were talking about how important it is for everyone to work together to protect our planet from asteroids. It really is a global effort, isn't it?
It definitely is. We're all Earthlings here.
Hmm.
And when you're facing a challenge like an asteroid potentially hitting Earth, you have to put your differences aside and work together for the greater good.
Yeah, it's amazing to see that kind of unity, especially when we're talking about something as potentially scary as an asteroid heading for Earth. But you've also mentioned all the incredible progress we've made in developing technologies to deal with this threat.
Oh, yeah. The progress just keeps going. We talked about kinetic impactors and gravity tractors, but those are just a couple examples. There are other really interesting concepts being explored. Some of them sound like they're right out of science fiction.
Ooh, I love the sci-fi angle. Tell me more. What else are researchers looking into?
Well, one idea that's been proposed is using focused solar energy.
Okay.
Basically, you would use a massive mirror in space to concentrate sunlight onto a small spot on the surface of the asteroid.
Interesting.
And that would vaporize the material and create a jet of gas that acts like a thruster, pushing the asteroid off course.
So it's like using the sun's power to create a giant cosmic hairdryer.
That's one way to put it, but you get the idea. It's a really elegant solution using the immense power of the sun for planetary defense.
It's amazing how creative some of these solutions are, but with so many options, how do we decide which one is best for a particular situation?
That's where it gets really interesting because there's no one solution that works for everything.
Yeah.
The best approach would depend on a lot of things: the asteroid size, what it's made of, how fast it's going, its trajectory, how much time we have, and the potential risks and benefits of each method.
Right.
It involves a lot of careful analysis, simulations, and collaboration between experts from all sorts of different fields.
So planetary defense is a really interdisciplinary field.
It is. We have astronomers, physicists, engineers, mathematicians, computer scientists, and even policy experts all working together to keep our planet safe.
That's incredible. It really shows just how complex and important this challenge is. But while we've been talking about the potential threat from asteroids, there's another side to this story, isn't there?
There is. Asteroids aren't just potential dangers. They're also really valuable resources for science. It's like they're time capsules from the early solar system. They hold clues about how our planetary system formed and how it changed over time.
So by studying asteroids, we can learn about the origins of our own planet.
Exactly. By analyzing what they're made of, we can understand the building blocks of planets and learn about the processes that led to the formation of Earth and the whole solar system. There's even the potential for asteroid mining in the future, extracting resources like water and minerals.
Wow, so these objects that we're trying to deflect could also be the key to future resources and scientific discoveries. That's fascinating.
It is. It shows how important it is to keep researching and exploring. The more we learn about asteroids, the better prepared we'll be to handle both the dangers and the opportunities they offer.
Well said. It's been a real pleasure diving into this world with you. Your insights have been incredibly helpful. So, for our listeners who have been with us on this journey exploring the potential threats and amazing advancements in planetary defense, what's the key takeaway? What should they be thinking about as we wrap up this deep dive?
I think the most important thing to remember is that while space presents us with challenges, it also offers incredible opportunities for discovery and innovation. We're living in a really exciting time where we're developing the knowledge and tools not only to protect our planet, but also to uncover the secrets of the universe. It's a journey of exploration, collaboration, and ultimately of ensuring a better future for humanity.
That's a great point to end on. It's a good reminder that even when we face these big cosmic threats, we have the power to shape our own destiny through science, ingenuity, and working together. So to our listeners, we encourage you to keep exploring, asking questions, and being amazed by the universe. Until next time, keep looking up, and remember, we're all in this together under the same stars.